In this video, we're going to show how we can show covalent bonding with dot cross diagrams, and by doing that we can sort of work out the formula of compounds and predict the formula of compounds. It's a very useful tool. Okay, so we're going to look at the dot cross diagrams of the following molecules. So I've drawn the top, the period 2 of the periodic table, the right hand side of it, starting with carbon. So and we're going to look at the molecule carbon forms with hydrogen, which is methane, which is CH4. Then the one nitrogen forms, which is NH3, it's ammonia. The one water does, which is H2O. Hydrogen fluoride, which is HF. And of course, neon doesn't form any bonds. And you probably see a pattern there already that it's 4 hydrogens for carbon, 3 for nitrogen, 2 for oxygen, 1 for hydrogen, and if you like, none for neon. Okay, so these are going to be our instructions that we're going to use. Those there. That is the instruction you've got to use for drawing a dot cross diagram. So let's start off with methane. So if I draw, remember dot cross diagrams, you only show the outer shells of electrons as well. You don't show the inner shells because they're not involved in bonding. Okay. So instruction 1 in blue there, it says place a dot and a cross in each overlap. So let's do that. Dot and a cross, and I'm saying the dots are coming from carbon and the cross is from hydrogen. Okay, so I've done that. The next step, it says 2 in black. For each atom, how many of its own electrons should it have in its outer shell? Well, carbon is in group 4, so it should have 4 of its own electrons. I've already drawn 4 dots, so that means I don't have to draw any more electrons. That's done for carbon. And for hydrogen, obviously it's done that, it's only got 1 electron. And finally, in red, the 4th point, check each atom has a full outer shell. Okay, so does carbon have an outer shell? Well, it thinks it's got, look, it thinks it's got 1, 2, 3, 4, 5, 6, 7, 8. So yes, it does think it's got a full outer shell. And all the hydrogens, they think they've got a full outer shell because they all think they've got 2, which is of course the full outer shell for the first one. Okay, so let's now do that for ammonia, NH3. So I'm going to follow the same set of instructions. Okay, so place a dot and a cross in each overlap. I'll put the H's in for the hydrogen here. Dot and a cross, dot and a cross, dot and a cross. Right. How many electrons for each atom? How many of its own electrons should it have in its outer shell? Well, nitrogen is in group 5, and so it should have 5 electrons. I've only drawn 3 dots, so that means I've got to draw 2 more. So there you go, 1 there, 1 there. Finally, the red step, check it, each one's got a full outer shell. Well, the nitrogen, it looks like it thinks it's got 1, 2, 3, 4, 5, 6, 7, 8. So that thinks it's got a full outer shell, and the hydrogens do as well. So that is our correct dot cross diagram for ammonia. Right, let's do the same for water now. Okay, so oxygen is in group 6, remember? Right, the first step, the blue step, a dot and a cross in each overlap. Dot and a cross, dot from oxygen, cross from hydrogen. The black step, for each atom, how many of its own electrons should it have? Well, oxygen's in group 6, it should have 6. I've only drawn 2 dots, so I've got to draw 4 more outside of the bonds. So 1, 2, 3, 4. And finally, the red step, check each atom has a full outer shell of electrons. So the oxygen, well, it thinks it's got 1, 2, 3, 4, 5, 6, 7, 8. So that's full. And each hydrogen thinks it's got 2, so that's the correct diagram there. Okay. So let's do the last one now. Let's do HF. I'll squeeze in over here. Right, so the blue step, sorry, H. The blue step, put a dot and a cross in each overlap. Okay, The black step, then for each atom, make sure you've added enough. So let's see, fluorine is in group 7. I've only got 1 dot there, so I need to draw 6 more. 1, 2, 3, 4, 5, 6. And then the red step, check that each atom thinks it's got a full outer shell. Well, that's fine because you've got 1, 2, 3, 4, 5, 6, 7, 8 electrons. The fluorine thinks it's got, and the hydrogen thinks it's got 2. So that is the correct dot cross diagram for that. Okay, so what does this show us though? Well, it shows us that group 4 elements like carbon, it would be the same for silicon, the next group down, they like to form 4 covalent bonds. Group 5 elements like nitrogen, they always form 3 covalent bonds. Group 6 like oxygen or like sulfur below it, they always like to form 2 bonds. And the halogens like fluorine, chlorine, bromine, iodine, they like to form 1 bond. And if you like, the noble gases, well, they form 0 bonds. So we've got a bit of a pattern there, which is quite useful to know. Right, let's just do one more example before we finish off. Right, we all know that chlorine goes around as a diatomic molecule. So chlorine goes around as Cl2. Let's try and draw a dot cross diagram for that. So chlorine is in group 7 halogens. So the blue step, it says draw a dot and a cross. I'm drawing this, let's say this chlorine as dots and this chlorine as crosses, so we don't confuse them. So the chlorine on the left, I've drawn 1 electron, 1 dot. I need to draw 7, so I need to draw 6 outside. So 1, 2, 3, 4, 5, 6. So that, and this chlorine, the same, it's going to have 6 outside. Now, the red step, check each atom thinks it's got a full outer shell. Well, each chlorine there thinks it's got 8 electrons, so that's fine. Okay, so that's the correct dot cross diagram for chlorine. And just checking there, yeah, chlorine's forming 1 bond, which we said it should do because it's in group 7. Okay, we'll leave that there. Now in the next video, if you want to watch it, is about double covalent bonds and how they are formed. And you probably come across double covalent bonds maybe when you're talking about ethene. They're molecules with a carbon-carbon double bond. So that's in the next video.